and number of outcomes. Experiment is a repeatable process that gives rise to a number of outcomes. Okay, an event is a collection of one or more outcomes. Okay, like heads, tails, what the dice landed on. A sample space is all possibilities. Okay. 2 fair spinners are spun. 1 to 4. What is the probability of the spinners indicating a sum of exactly 5? How would you do that?
Do we need to show every possible outcome that could give 5 from the 2 spinners?
Yep, I'm not doing that. Okay, here we go. What's the probability of getting exactly 5?
Assuming a quarter.
Yep. What's the probability of getting more than 5?
Is that going to be 6 over 16?
Yeah, I prefer your second answer. You didn't simplify it. I would say the first one is 4 out of 16. They've simplified it to 1 over 4. Maybe I'm wrong. At A level, it's all good. I like to keep a common denominator. 16, 16. If this was a quarter and this was eighths, you now have to unsimplify it if you wanted to add those two together. But actually, no. At a A level, you have a calculator. I suppose it's all the same. Okay. How about this one?
Is that going to be something like 19 over all of the numbers added up?
Yeah, 19 over total. How about B?
12.5 minutes. Isn't that where I need to now take a bit? Oh no, so that's just like, so 10.5, which is 3/4 in between 9 and 11.
Very good.
Is that like I need to times 12 by 3/4?
I think it would 3/4 would be less than that, wouldn't it? In that group, 10.5 is there. We want over 10.5.
So am I just doing? Am I doing 4 plus 5 plus 9?
You're thinking of less than. In this group, 9 people are less than 10.5. We want over 10.5.
Oh. So do I need to do a quarter times 12?
Yep.
And so that would be plus 3.
Yep. And that would be that over the total. Yeah, cool. So you can see why I skipped lots of stuff. You're a big boy. You'll do some histograms or something. Well. Okay, Venn diagrams. Let's see. The student is not in the choir. You draw a Venn diagram and you fill it in. You draw 3 circles and you fill them in. I have every faith in you. It involves some algebra. Alright, we'll do some algebra. Oh no, we're not doing that. Find x, find y. Alright, I'll do my job properly. Let's see. Let's try this one. No, sorry, let's not. It's too easy. It's just too easy. This one might be worth doing. Yeah, I hope. Yeah, let's try this one.
So I first of all need to do 1 minus all the values that I've got here, so that I know what the maximum value can be from now on.
Yeah, okay.
And so that'll be 1 minus 0.32 minus 0.07 minus 0.13 minus 0.1.
Fine.
And I get 0.38.
Okay.
And so now, so I feel like with Q and P and 0.07, I need to do something there.
Make an equation. Any equation.
Yeah. Am I
involving
like
involving P and Q?
Should I do Q is equals to 0.38 minus P? Oh, yeah.
Yeah. P plus Q equals 0.38.
Yeah.
We know that much. We also are told this.
That probability of M is the same as probability of P and probability, and so that means that 0.32 plus P is equals to P equals to P plus Q plus 0.07. And so now if I do P is equals to 0.38 over Q minus Q, sorry.
Yeah.
And then I can just sub that value of P in.
Yeah, it's still too easy. I thought it would be simultaneous equations, but actually you have P on both sides, and so actually that's a linear. You would just solve for Q and just sub the answer in there.
Yeah.
Even if it was simultaneous equations, you'd be fine. I thought it'd be worth doing one. It wasn't. Okay, this might be mutually exclusive, and in the, you know what, Andrey, if we have time at the end, enrolled men, we'll do some of this. Is that the whole chapter? Right. It wasn't what I thought. Was not what I thought. All the binomial stuff must just be in here. Binomial probability must be in chapter 6. Yeah, I knew. Gee, I don't feel bad about skipping the first 4 chapters. Okay, I've marked this as very important. We have to do this.
Yeah.
Okay, let's try this.
Okay, so so head. Tail. I feel like I'm not doing this the way, but
I would do it systematically. So head, and then do head, and just change one thing, tail.
Yeah.
And then go from there.
Head, tail.
Yeah. No. Head, tail, back to head.
Oh, right, sure, fine. And then tail, head.
No. Head, tail. Do it in that order. So head, tail. Tail. Head. It's like you want to be a computer nerd. You'll have to do binary. And so that's 1. That's 2. 3. 4. 5. 6. 7. And that's the way you'd go about it.
So am I now doing tail, head, tail?
Tail, head is even
Tail,
lower.
head.
Yeah.
Tail, head.
Tail, head, tail. It's like hundreds, tens, units.
Are we now going back to? We can't go back to head, tail, tail. Are we now doing head, tail, head?
We now do tail, tail at the start.
Oh no.
That's head, and then the very last one.
Tail, tail, tail.
Yeah, tail, tail, tail. And I marked this as very important for some reason. Okay, how about B? Writes the probability distribution of X as a table. As a table. I'm looking it up. And oh, it's the number of heads. And so we have X is the number of heads, and the probability that X is X. And so, what are the possible number of heads that we can get?
Like the maximum possible number we can get.
All possibilities. What's the smallest? What's the most? What's the? These are coin flips. We flip 3 coins. What's the fewest number of coins can land on heads? What's the highest number?
0.
Yeah.
3.
Yeah. Any other possibilities?
1 and 2.
Yeah. Okay. Probability of each.
Okay, so probability of 0 would be a 9th.
Mm-hmm.
Probability of 1 would be 1, 2, a third.
Let me think. Yeah, I'm doing it as 3/9.
Okay.
No. Is it 3? Yeah. 1 head. 1, 2, 3. 3/9. Yeah. Okay.
And 4/9.
Yeah.
And 1/9.
That's it. And writes the probability distribution of X as a probability mass function. Have you seen that before?
No.
It's been a very long time since I taught this, but I think it's something like the probability that X equals some specific X. Like, what's the probability that in general, do I have it the other way around? Might be small x first. No, big X. Yeah, so the probability that the X is either 0 or 1 or 2 or 3 equals, and we have to come up with some formula that when you sub in 3, you get a 9th. When you sub in 2, you get 4/9, that type of thing. No, we're not there yet. It's simpler than that. It's just, you cheek this man, it's 8ths. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 possibilities. And how many had 2 heads? 1, 2, 3. That's 8. That's 3/8. Yeah, I was expecting the same thing twice in the middle. That's it. And so 1/8, 3/8, and 0. What outcomes have a probability of an 8th?
Is that going to be 1, 2?
So that is 1 and 2.
Yeah.
Next one. No. 1/8 is no. What outcomes have a probability of 1/8?
0 and 3.
Yeah. Probability of 3/8?
1 and 2.
That's it. And I think you down here you'd say something like all other possibilities or something. Oh, otherwise. Yeah, anything else, the probability is 0. And so that's just to complete it. That's what it looks like. Okay. And so that's what this stuff is all about. Okay. Any questions about that?
No.
So here is like it's 8 possibilities, and it's quite like, this is the raw data. Here it's been put into a table. It's been summarized down for us. And then here it's been put into a probability mass function, a different type of summary. Instead of having 1/8, 1/8, we can say it's just there once, and then they just list those. Yeah. 0, 1/8, 3, 1/8. Here we've just got 1/8, 1/8, 0/3. So it's a bit simpler. All right. Exam question already, right? How about this one?
Okay, so probably different. So am I just doing a quarter plus a half plus 3/8 plus an eighth? Sorry.
That would be if this was or equal to there.
Is it just going to be a half plus an eighth?
Yes.
Yeah.
X could be 2 or 3. That's it. What is B?
A quarter plus an eighth.
Yeah. What is C?
Probability X 0.
Yep. That's 0. And B was 1/8 plus 1/4. And you get the answers for those. That's great. Okay, how about this one? Oh, any idea what? No, you won't know. The name of this distribution. If everything has the same probability, I think I skipped. Oh, I don't remember. I think it's called like an equal distribution. So what's it called? Discrete uniform distribution. That's it. And it's discrete data, so it's discrete uniform distribution. Okay, how about B?
So probability random. So is it just going to be 4/20?
I think it's 5/20 because it's 16, 17, 18, 19, 20. Yeah, because you include 20.
Yeah.
Yeah, 20 is included. Yeah, you get the idea.
Yeah.
Let me see. How would we do question C?
Will it just be a quarter?
How did you get that?
I did a half times a half.
That would be less than or equal to. This is just less than.
Is it going to be 9? Is it 9/20 times 9/20?
I believe so. 9/20 squared.
Yeah.
That's fine. Let me just make sure on that one. Yeah, 9/20 squared, 81/400. That's fine. Hang on. I need to go to the bookie. So I wasn't expecting. This was 6.1, is it? Hang on. Statistical distributions, yeah. Probability distribution. I think, oh yeah, so it is good. It is good. Okay, how about this one? Any idea how this thing works?
So not entirely.
So you might have no clue whatsoever. This is the thing where it's a formula that gives you the probability. So basically, well, what do you know about the probability of 1 or 2 or 3 or 4?
That one of them is more likely to happen than the other.
No. What is the probability of getting a 1 or 2 or 3 or 4?
So it's a four-sided dice.
Yep.
A quarter.
No, that's the probability of getting one of them. What's the probability of getting 1 or 2 or 3 or 4?
1.
Yes. And another way is you sub 1 for x. So that's how it works. So it's basically k over 1 plus k over 2. So when x is 2, the probability of getting a 2 is k over 2. The probability of getting a 3 is k over 3. But we don't know what number k is. Plus k over 3 plus k over 4. And so in total the probabilities are 1. And solve for k.
Okay, so do I put in my calculator?
Yep. And k is 12 over 5. All right. Sorry, 12 over 25. That's what calculator should say.
Yep.
And so give the probability, we could do it as a table. Okay, so for the table, x and the probability that x equals x. And so what goes in the table? Possible outcomes for x. Or possible events. What can the dice land on?
It can land on 1, 2, 3, or 4.
Yeah, so that's little x. 1, 2, 3, or 4. Okay, what is the probability it lands on 1? Using the formula, and you now have k.
So will it be just 12 over 25?
Yeah. Next one.
So is x meant to be equals 2 in this scenario?
Yep.
And so it becomes 6 over 25.
Great.
Then 4 over 25. And then 3 over 25.
That's great. And 12 plus 6 is 18. plus 4 is 22, plus 3, 25. 25 out of 25. Yep. And then C, probability X is greater than 2. You can use a table. Probability X is greater than 2.
Sorry, what are we doing now, sorry?
C, probability X is greater than 2.
So are we now doing 4 over 25 plus 3 over 25?
Yep. What's that?
So 725, yeah.
Yeah, so that's you're good for that bit. So that's what this is now. So we started off with something on page 8. We started off with something raw data, head, lots of stuff. You could have, a lot of data. I mean, imagine there were 4 coins, you could get a lot of information. We summarized it down to a table, which is less information. Like it has the same amount of information, but it's more compact. And then we've summarized that down even to this one. So we didn't have an eighth twice. We didn't have 3/8 twice. It's a bit like a stem and leaf diagram. And then we compacted that down even further to just this. A formula that gives you the probability of X given X. So what is the probability of 3? The probability of 3 is 12 over 25 divided by 3. Probability of 1, 12 over 25 divided by 1. Whatever you want the probability of, it is 12 over 25 divided by that. And so you just compute it. And so it's even compacted down even more. Okay, exam time.
Show that K is equals to 1 over 10. Okay, so are we just going to do 1? So we need to say equals to 1, and then do we just do 1 times 1 over 10 plus 2 times 1 over 10?
No. So that's true. That's very true. Pretend that isn't there. Solve for K. Something like that. Find K.
Okay. And so are we just going to do K plus 2K plus 3K plus 4K equals to 1?
Mm-hmm.
And equals to, I'm assuming K is equals to 1 over 10.
Don't assume. What's 1K plus 2K plus 3K plus 4K?
That is 7K, 9K, 10K.
Yes. And now you can write down K equals 1 over 10. Like they assume you can divide both sides by 10. They give you 1 over 10. And so you have to be careful to show that not to work in reverse. That would be what you're talking about is verify. Verify. If they said verify that K is 1 over 10, you would sub it in and show they add up to 1. Show that would be, if they didn't give you 1 over 10, how would you find K? Yeah, you find it forward. Okay. Right. A.
Okay, so K plus 2K plus 3K plus 4K plus 5K equals to 1. 15K equals to 1. K equals to 1 over 15.
Yeah, probably.
That X is greater than 2. So we're just gonna do 3 over 15 plus 4 over 15 plus 5 over 15.
Yep.
And that is 4 over 5.
4 over 5. So it must be 12 over 15. Oops. 4 over 5. Great. Very good. Okay. This time, I'll let you see how you do.
Okay. Okay, so I think here I need to do a k plus 2k minus plus a k plus 3k plus 3k.
Mm-hmm.
I think it's 3k.
Oh, I wrote. Okay. Sorry, I said yes and wrote the wrong one.
And then it equals to 1.
Yeah.
And then just so that's k is equals to an 1/8, I think.
Yeah. And you'll be fine for B, I believe. Go on then. What is B?
I think I'm just going to do just an 1/8 and then times 2 minus 1 plus 3 times an 1/8 and then plus an 1/8 times 4 minus 1 is the answer.
Yeah. And you can use this thing here. An 1/8 plus 3/8 plus 3/8. Like you already did that.
Yeah.
Bit there. What would you get?
So
1 plus 3 plus 3.
that would be 7.
Yeah, 7/8.
Yeah.
And I just realized something. I think that is exactly this one. 3/8, 3/8, 1/8. So probability of that is, yeah, they wrote it as, this is 0, 1, 2, 3. That one was 1, 2, 3, 4. But probability of greater than that one is 7/8. So I think they just rewrote this exactly. So yeah, you could see how this one you could write as kx, and this one is what was it again? 3 something. Kx minus 1. Okay, so yeah, kx minus 1. So I think it's exactly this one. What was it going to say? Yeah, all right. I was kind of noticing these things. I was going to mention whatever. There's only 4 possibilities, so you did 3. If there were a lot more, you can always do 1 minus just this one. So the probability that x is greater than 1 will be the same as 1 minus the probability that it's less than or equal to 1. That is just 1. So instead of adding up those 3, you could find 1 and do 1 minus it.
Okay.
Let's see. You're gonna be fine. Not doing that. Right. This one looks at least decent. Yes. Okay, let's do this one.
Okay. So it says x is 1, is 0.8. Does that mean 2/8? Sorry, does that mean that after the first roll it's always going to be 0.28 or? Oh, is that saying that the probability of it landing on 1 is 0.28?
Yep. So I want this as a table. So how do we do table?
Are we just doing the same table we just did now, where we put like X in and stuff?
Yeah, go on. You have to say it.
So X and then 1, 2, 3, 4.
Yeah.
And then do we then do probability of X equals R at the bottom?
Well done. That's 1, 2, 3, 4. Yep.
And then are we now just doing? So they put some sort of thing like R is for 1 and 2. Does that mean, do I put 0.28 for the first answer basically?
So I believe that's 0.28. Yeah.
Yeah.
Okay.
The probability that it lands onto. Do I need to? So is it now going to be 5? Do I do 5 minus 2 or something? I'm not really sure.
I think so. Yeah. So R is 2.
Yeah.
And so the probability that X equals 5 minus 2, right? What's that?
X equals to 3.
So that's
Probably.
probability X equals 3. What was before that?
Probability that X equals to 1.
What is R for this one that we're doing?
1.
No. What was R?
Oh, 3.
No. What did you sub in for
R? 2.
Yep. R is 2. So the probability that X equals 2 is the same as the probability that X equals 5 minus 2. And so it's probability X equals 3. So these two are actually the same. 2 and 3 are the same.
Okay.
Do that again, but for 1.
It'll give me 5 minus 1, so X equals 1 is equals to X equals 4.
Yeah.
So that means that we put 0.28 for 4.
Yeah.
And then do we then do 1 minus 0.56 and then divide that answer by 2 to get what 2 and 3 are?
That's it.
And so 2 and 3 are both 0.22.
0.22. That's great. So it's been a very long time since I last taught this, so I'm not very familiar with it, but that's it. So that's how that works. So that's another, you can see just how condensely they've compacted this down. It's not even 2 separate formulae. It's like down to one thing, and you can, from that, create a whole table. Let me see. A dice is rolled twice and the totals are added together. The probability the total is 7 or more. How would you get the probability the total is 7 or more? Let me, before we do that. This is the binomial thing. I think what I'd probably do is, how can you get an outcome of 7? If you roll 1, 2, 3, 4.
Let's roll twice in total, so I had to get one goal to total 7 or more. Yeah, so am I just saying the kind of probability that we need to get for that to happen? Isn't it? It can only be with 3 and 4.
Yes, and so
4 and 4.
it's either the probability of, what are the successful outcomes?
3, 4, 4, 3, 4, 4.
Yes, so you'd get that plus probability of 4 or 3 plus probability of 4, 4. And so how would you do that?
We would do 0. So are we doing?
Sorry, I opened my calculator.
Yeah. Will it just be like doing 0.22 times 0.28?
Yeah.
And then plus 0.22 times 0.28.
Yeah.
Plus 0.28 times 0.28.
So try that. I want to see if it works.
Actually, it might be 1 over 0. It might be 0.28 over 100. Or 1, sorry, over 1. Is it meant to be, sorry?
What is 0.28 divided by 1?
0.28.
Yeah. It's kind of given that. Yeah.
So I got probability of 126 over 625. Yeah, 0.2016 as well.
Great. That's it. I did it. What way did I do this? Something to the power of 4. I did it as I don't know how I did it. It's been so long, but okay, we have the idea for this one. All right, any questions there?
No.
Okay, I thought that I could use binomial probability, but I can't because the probability changes. Let me change that 0.28 or something. Number of trials, I don't know. Okay, let me see this one. Given that is that, nah, that's fine. I'll put that back on. Then we have all these review exercises. So these aren't of the highest quality. Okay, yes. Okay, how about this one? Might be the binomial, I don't know. Okay, how about this one?
Okay, so if it lands 4 times in total, does that mean that they've got 4 blues in total?
I think that's the maximum. So the spinner is spun until it lands on red or has been spun 4 times in total. So S. So we want the probability S, X equals S. The number of times it's spun. Okay, so how many times can the spinner be spun for this one?
4 at max.
And minimum?
1.
And so I'm going to say S and the probability S equals S. And it can either be once, twice, 3 times, or 4 times. And so if it's spun only once, that was when it landed on red the first time. Is that right?
Yes.
Okay. And so what's the probability it's spun once?
2/5.
Yeah. Okay. How about the next one?
Will that then be 2/5 times 2/5?
It wouldn't be 2/5. Basically, the probability that S is 1 is the same as the probability of getting a red.
Yeah.
The probability that S is 2... Yeah, go on.
No,
Well,
I was going to say, no, I think I was wrong.
what would have to happen for it to be spun twice? What outcomes would cause it to be spun twice?
Getting a blue.
Blue first time, and then?
A blue second time.
You keep spinning until you get a red, or you hit 4 spins.
Red second time, sorry.
Yes. And so we want the probability of blue, then red.
Yeah, and so that'll be 3/5 times 2/5, which will be 6/25.
That's it. Okay.
And then do we do BBR? And then
Yeah. What's that one?
that'll be 3/5 times 3/5 times 2/5.
Yeah. I'm going to write it as 3/5 squared.
And I've got 18/125.
Okay.
And then for 4, it's just going to be 4 Bs. So just 3/5 to the power of 4.
Times 2/5. Well done. And then that one is 3... Hang on. Oh, you already gave me the answer, that way. And then that one, yeah, the probability S equals 4 is just 3/5 to the 4. They must have
And
all...
I got 81/100 over 625 for 4.
Great. And it simplifies down. The fraction simplified, does it?
Okay.
Yeah, 81/65. What was I going to say? Oh, no. Hold on. Is there another possibility at the end? Oh, or maybe put 81/625 into your calculator. What do you get? Is that what the calculator said?
What am I putting in, sorry?
81/625. 1 second. We press SD 0. I know why, Andrey. What else could you get on the fourth spin?
BBBR.
Correct. That would also be 4 spins. And so the long way of doing this would be 3/5 to the 4 plus what?
3/5 to the 3 and then times 2/5.
Yeah. Or easy way would be 1 minus 1, 2, 3.
Yeah.
Great. Okay. All right, let's try this one.
Is that the same thing as we just did?
Yep.
So it's firm. So, okay. So we're doing another table, aren't we? Yeah. the 5 outcomes, sorry. Oh no.
So yeah, you're right. So 1, 2, 3, 4, 5.
Yes. And so now, okay, so for 1, it'll just be 3/7.
Great.
And then for 2, will it be 4/7 times 3/7?
Yeah.
And that's 12/49.
12/49. Yeah.
And then for 3, will it just be 3/7 squared plus 4/7?
Yeah. No, times.
Yeah, sorry, times. Which is 36/343. Oh, sorry, and then I'm doing 3/7 cubed times 4/7.
Mm-hmm.
And that's 108/2401.
Okay.
And then here, do we just do 1 minus all those previous values?
Well done.
So that would be 1 minus 3/7 minus 12/49 minus 36/343 minus. I got 424 over 2,401.
I should have put it here. 2401. 81/2401. 108. Oh, you found the probability. It lands on 1, 2, 3, 4, 5, 6, 7. Which represents number of times. Hang on. The first 7 is put until it lands on green. Until it lands on green, not until it lands on purple. Okay. We get here. Let me. Purple. There you go.
Good, thanks.
Full marks. Let me just see this one. So this is the same idea, except it is 2/3 and 1/3. It's tossed 4 times. You know, you stop playing when it's 2/3 or 1/3. And it's either, once, twice, 3 times, 4 times. Yeah, there you go. 2/3. They didn't use squared. They did it the long way. Jesus. For 1, they should have just, so for 4, they should have just done 1 minus. It would have been much easier. Yeah. Then we have some review exercises. The quality of them isn't always the best. And so, yes, that stuff. What do you give yourself?
Probably a tick.
That's great. How was FU, Andrey?
That was good, thank you.
And so, mechanics next time?
Yes, please, yeah.
Any questions in general?
I think that's it.
Alright, well done, Andrey. You did great. And I look forward to talking again next time, and have a nice weekend.
Cheers, you too. See you on Monday.
Alright, goodbye.